Engine diagnostics. Diagnosing engine performance issues is a key skill for automotive technicians. Engine problems like misfires, poor fuel economy, and general performance issues can be caused by a wide range of factors, from faulty sensors to worn-out components. This lesson will cover the diagnostic techniques used to identify and resolve common engine problems. Additionally, learners will be introduced to the tools required for in-depth engine performance analysis, such as OBD2 scanners, multimeters, and oscilloscopes. Diagnosing engine misfires. An engine misfire occurs when one or more cylinders fail to fire properly, causing the engine to run unevenly. Misfires can lead to poor engine performance, reduced fuel efficiency, and increased emissions. Symptoms of engine misfire. Rough idling. The engine may shake or vibrate when idling. Loss of power. Acceleration may be sluggish or uneven. Check engine light. The check engine light will typically illuminate, often accompanied by a misfire-related DTC. Increased emissions. Misfires lead to incomplete combustion, increasing exhaust emissions. Common causes of engine misfires. Ignition system issues. Faulty spark plugs or ignition coils can prevent proper ignition in the cylinders, leading to misfires. Worn-out spark plug wires or poor connections can also cause misfires by disrupting the ignition spark. Fuel system problems. Clogged fuel injectors or a faulty fuel pressure regulator can result in insufficient fuel delivery, causing misfires. Low fuel pressure due to a failing fuel pump or clogged fuel filter can lead to improper combustion. Air intake issues. Vacuum leaks or a dirty air filter can cause the air-fuel mixture to be off balance, leading to misfires. Faulty mass airflow sensor can misinterpret the air intake, leading to incorrect fuel delivery. Engine compression problems. Low compression in the engine cylinders due to worn piston rings, valve seals, or gasket failures can cause misfires. Diagnosing engine misfires. Check engine light and codes. Use an OBD2 scanner to read the trouble codes stored in the vehicle's computer. Common misfire codes include P0300 and specific codes for individual cylinders. Spark test. Use a spark tester to check the spark at each spark plug. If a spark is absent, the issue may lie in the ignition system. Fuel system test. Use a fuel pressure gauge to check if the fuel system is delivering the correct amount of fuel. Also, check for proper fuel injector operation using an injector pulse tester. Compression test. Perform a compression test to check for engine cylinder health. Low compression may indicate internal engine damage. Diagnosing poor fuel economy. Poor fuel economy is often a symptom of inefficient engine performance. A variety of factors, from fuel delivery issues to sensor malfunctions, can cause a vehicle to consume more fuel than usual. Symptoms of poor fuel economy. Reduced miles per gallon. The vehicle requires more fuel to travel the same distance. Poor acceleration. Reduced throttle response may indicate the engine is not operating efficiently. Increased exhaust emissions. Excess fuel that does not combust properly leads to higher exhaust emissions. Common causes of poor fuel economy. Faulty oxygen sensors. Oxygen sensors monitor the exhaust gases and send feedback to the Engine Control Module, ECM, to adjust the fuel-air mixture. A faulty sensor can lead to an incorrect fuel mixture, causing poor fuel economy. Dirty air filter. A clogged or dirty air filter reduces airflow to the engine, causing the engine to work harder and consume more fuel. Fuel injector issues. Clogged or malfunctioning fuel injectors can cause uneven fuel distribution, leading to poor fuel economy. Low tire pressure. Low tire pressure increases rolling resistance, causing the engine to work harder and use more fuel. Driving habits. Aggressive driving, such as rapid acceleration and heavy braking, can drastically reduce fuel efficiency. Diagnosing poor fuel economy. Check OBD2 codes. Use a scanner to check for any codes related to the fuel system, oxygen sensors, or air-fuel mixture. Inspect the air filter. Replace a clogged air filter to ensure optimal airflow to the engine. Test fuel injectors. Inspect fuel injectors for proper operation using an injector pulse tester and ensure there are no blockages or leaks. Check tire pressure. ensure that the tires are inflated to the correct pressure. Underinflated tires can lead to poor fuel economy. Using diagnostic tools for engine performance analysis. Effective diagnosis of engine performance issues requires a variety of diagnostic tools. These tools help technicians identify problems with the fuel, ignition, and air intake systems. OBD2 scanner. The OBD2 scanner is essential for reading diagnostic trouble codes and monitoring real-time engine data from the ECM. How to use. Plug the OBD2 scanner into the OBD2 port under the dashboard. Turn on the ignition and retrieve stored trouble codes. Analyze the data for misfires, fuel mixture problems, and sensor malfunctions. Multimeter. A multimeter is used to test the electrical components of the engine control systems, such as ignition coils, fuel injectors, and sensors. How to use. Set the multimeter to measure voltage, resistance, or current as needed. Test components such as spark plugs, coil resistance, and sensor signals for proper function. Fuel pressure gauge. A fuel pressure gauge is used to measure the pressure within the fuel system, ensuring that the fuel injectors are receiving the correct pressure. How to use. Attach the gauge to the fuel rail or test port on the fuel system. Start the engine and observe the fuel pressure reading. Compare the reading to manufacturer specifications. Low or high fuel pressure can indicate issues with the fuel pump or pressure regulator. Compression tester. The compression tester is used to assess the health of the engine's cylinders by measuring the pressure they produce during cranking. How to use. Remove the spark plug from the cylinder to be tested. Screw the compression tester into the spark plug hole. Crank the engine and record the pressure reading. Low compression readings indicate potential issues such as worn-out pistons, rings, or valves. Summary of engine diagnostics tools and techniques. Here's a table showing the summary of engine diagnostics tools and techniques, including their purpose and techniques. You can pause the video if you want more time to review the table. Conclusion and recap. In this lesson, we covered how to diagnose engine misfires, poor fuel economy, and other performance issues using OBD2 scanners, multimeters, fuel pressure gauges, and compression testers. We also explored common causes of these issues and discussed how to use diagnostic tools effectively. Mastering these techniques is essential for diagnosing engine performance issues